advanced, something that actually makes a difference in the shop floor. We are going to talk about some special CNC tools. Now, why is this important? Because in real machining, time, accuracy, and tool selection decides everything. Two people may have the same machine, same drawing, same material, but the one who knows the right tool will always finish faster, safer, and better. So, in today's session, I'll be introducing you to five very important special tools that most beginners either ignore or may even don't know they exist. We will not go very deep into theory. I'll explain in a very simple and practical way so that after this session, when you see a job, you will start thinking, shall I use that? Shall I use this? Can I use that instead of just an end mill for everything? That is the goal. Hmm? So let's get started. Before we jump into the special tools, let me ask you something. Why do most beginners struggle in CNC? Not because the machine is complicated, not because the program is difficult. The real program problem is they try to do everything using the same tool. They get comfortable with one end mill and then they try to use it for every operation. Now, what happens? When the part becomes slightly complex, like a hidden groove or an angled slot, they're confused what to do. They either compromise the design or take too many setups. Or worse, they damage the tool or part. And then they think CNC is very difficult. But actually, the problem is not the CNC. The problem is tool awareness. If you know the correct tool, half your machine, half your machining problems is already solved. So today, I'm going to show you tools that solve these exact problems. And once you see them, you will realize, okay, this is what I should have used. So, what exactly are we going to cover today? First, I'll be briefly explaining what we mean by special CNC tools. Then we go tool by tool. And then I will show you where each tool is used, why it is used, and very importantly, when not to use it. Because knowing when not to use a tool is as important as knowing when to use it. I'll also try to share some real shop floor insights, things that doesn't usually find in textbooks. And by the end of the session, you will clearly understand these five important special tools that can make your machining faster and smarter. So please be with full attention because this kind of knowledge that directly improves your practical skills. Let's start with a very interesting tool called the lollipop tool. Nice to hear the name, right? Just observe the shape carefully. You will notice something different. One, it looks like a lollipop. Second thing, the ball portion on top, it is smaller than the shank. Now, why is this important? Let's imagine a situation. Suppose you are trying to machine a hidden groove or an undercut area. If you use a normal end mill or a ball nose tool, what will happen? The shank will hit the material before the cutting edge reaches the required area. So even if your program is correct, physically the tool cannot reach. And that is exactly the problem we will solve here. Because of this reduced neck and the smaller board, the tool gets more clearance and it can go inside and machine those hidden regions. That's why this tool is mainly used for undercuts, reverse profiles, complex 3D surfaces, etc. In simple words, this tool reaches where normal tools stop. Now, let's see where this tool is actually used. This is where things become very clear. Okay. Lollipop tools are mainly used in situations where the cutting area is not directly visible or accessible from the top. For example, in mold and die components, you often get small undercuts or reverse curves. In parts like impellers or turbine blades, there are complex shapes where the surface goes inward. In such cases, a normal tool can only reach the outer surface, but the inner or hidden portion remains unmachined. This is exactly where the lollipop tool is used. Because of its shape, it can go inside, below, and around the feature. So, whenever you see a reverse groove, a hidden edge, or a surface that bends inward, you should immediately think this will be a lollipop tool application. Let's see the limitations. I told you this tool is very useful, but let's also it is also very sensitive. Let's understand the limitations. First one, it has very low rigidity because the neck is thin and extended. The tool is not very strong compared to the normal end wheels. So if you apply high cutting forces, it will start bending or vibrating. Second, high risk of breakage. If the feed is too high or depth of cut is too much, the tool can break very easily. And remember, this is not a cheap tool. This is not meant for heavy industrial removal. This is a finishing or a light cutting tool. If you use it for roughing, you are automatically asking for trouble. And finally, the programming must be very, very careful. Right? The toolpath, the step power, the step down, everything should be controlled. Because one small mistake can lead to collision or tool failure. So always remember this is a precision tool, not a power tool. Next, let's move to the next important tool, the T slot cutter. This tool is used to create a very specific shape called the T slot. You would have seen this in the machine tables, CNC tables, or the milling machine tables, most of the places where clamping is done, especially in the VMC machine. This is used for the clamping components using bolts and nuts or the bolts and fixtures. Now, why it is called T slot? Because the cross section of this slot looks like the letter T. There is a narrow opening at the top and a wider portion inside. Now, here is the most important point. You cannot directly use a T-slot cutter on a solid surface. First, you have to create a normal straight slot using an end mill. Then this tool is used to expand the bottom portion. That's how the T shape is formed. So always remember, T-slot cutter is a second operation tool, not a starting tool. Now let's see where this tool is actually used. The most common place you find the T slot is on the machine tables. If you have seen a VMC machine, the table will have multiple T-shaped slots. These slots are used for clamping the workpiece. Bolt slit inside the slot and then fixtures or components are tightened on the top. This allows strong and flexible positioning. Apart from the machine tables, T-slots are also used in fixture plates, custom work holding setups, and sometimes in sliding mechanism. So this is not just a machining feature, it is directly connected to how we hold the job. This is why this tool is very important in practical machining. Whenever you see a requirement for clamping or adjustable positioning, you should immediately think of T-slots in your mobile. Now, let's move to the next important tool, the woodruff key cutter. This tool is mainly used for machining keyways on shaft. Now, what's a keyway? Whenever you have a shaft and you want to fix a gear, pulley, or coupling on it, you need something to lock them together so that both rotate together. That locking element is called a key, and the slot where this key sits is called a keyway. Now, the woodruff cutter is specially designed to create a semicircular keyway, unlike a normal slot. This is not straight at the bottom, it has a curved profile. Because of this shape, the key gets better seating and alignment. So, whenever you're working with shafts, gears, pulleys, and you need a proper locking arrangement, this tool is used. Now, see, this woodruff cutter, some people might have confusion just now. Means this just looks like a T-slot cutter, right? We'll go for a comparison between this. Now, this is a very important comparison because people get confused between these two tools. At first glance, both may look slightly similar, but their purpose is completely different. Let's understand clearly. First, woodruff cutter. This is used on shafts to create semicircular keyway, which is used to lock components like gears or pulleys. And one advantage is it can directly plunge into the material. Now, T-slot cutter. This is used on the flat surfaces like machine tables. It creates a T-shaped slot which is mainly used for clamping. And very importantly, it cannot be used directly. You must first create a straight slot and then use this tool to widen the bottom. So even though both tools may look similar, one is for power transmission or shaft connection, the other is for work holding clamping system. One, the woodruff, it will be a semicircular keyway, and here it will be a flat slot. Never get confused between these two. Now, let's move on to another very important tool, the dovetail cutter. This dovetail cutter, it is used to create angled slots. Unlike normal slots, this is not straight. Both sides are cut at an angle, forming a shape like a approximate like a V. Why do we need this shape? Because it creates a locking effect. When one part slides into another, it cannot easily come out vertically. So where is it used? It is used in geometries like machine slides, guiding systems, precision assemblies, etc. That's why it is called a dovetail because the shape holds the parts together. These cutters come in different angles. We have 45 degrees, we have 60 degrees, etc. depending on the design requirement. So, whenever you need a requirement where two parts need to slide and stay aligned, this is the tool used. In simple words, this tool doesn't just cut, it creates a locking system. Now, Let's see where this tool is actually used. The most common application is in the machine slides and guideways. If we observe closely, many machines use dovetail shapes for guiding movement. Why? Because the angled slides hold the component in position while still allowing smooth sliding. Apart from that, the dovetail profiles are also used in fixtures where parts need to be locked securely. Precision assemblies where alignment is very important. And even in tool holding mechanisms. So this is not just a cutting operation, it directly affects how parts move and how accurately they stay aligned. Whenever you see design that components need to slide but not lift, you should always think of a dovetail. You can see in this image here, this is the dovetail design here. This means that it can move in, for example, in one direction can but it cannot come up or move in other directions. Now let's look at the final tool for the day, the most interesting or most special tool, the thread milling tool. Normally, when we want to create threads, we use a tab. But in this method, we create threads using a milling cutter. Now, how does this work? Instead of going straight inside a tab, this tool moves in helical path. So it tapping. This is the traditional method. It is fast and simple to use, but it has one major problem. If the tool breaks inside the tool, removing it is very difficult. Sometimes the entire component can get rejected because when we're using the first tab, it will be very tight if the hole is not proper. That, for example, M6 tab, you have to drill 5.5, 5.0 and drill. And at that time, if the hole is little smaller or it's angled or anything, what will happen is when you turn the uh, tab, using the tab runs, there are chances that this tab gets stuck inside the hole and it gets broken. But in thread milling, here you're using a milling cutter with a programmed helical movement. So you can have much better control. The biggest advantage is the same tool can be used for different thread sizes. And even if something goes wrong, the tool will not get stuck like a tab. So it is much safer, especially for expensive components. In simple terms, tapping is fast but risky, and each tab, each size needs a different set of tabs. We need a separate tab for M6 tapping. We need separate tab set for M5. We need separate for M10, whichever it is. We need a separate sets. But in thread milling, it may be comparatively slower, but it is smarter and safer. And the single tool we can use for multiple thread holes. And in modern CNC machining, this method is becoming more and more common. So that's it for today's session. Today we did not just discuss about the tools, we understood how tool selection changes everything in machining. Most beginners focus only on machines, but professionals focus on choosing the right tool for the right job. And that's exactly what makes the difference. Now, if you are someone who wants to learn CNC programming properly, not just theory but practical understanding, our 45 days CNC operator come programming course, it's going to start on May 11th. In this course, we cover everything from basics to real life shop floor concepts like what we discussed today. If you are interested, you can contact us and you can join for the course. It's a 45 days course where we'll be learning basics, we'll be learning the CAD software and also a CAM software. No pressure, just an opportunity. And once again, thank you for joining. I will see you in the next session. Thank you. Have a nice day. Please, if you have any doubt, please put it in the comment section. I'll try to reply. Thanks a lot.